Once we know how to identify and interpret the slope of a linear function, construct a linear function, find intercepts, basically have all the tools that we need in order to be able to graph linear functions. There are multiple different methods for doing this. One is to use intercepts. That's what we just did in example 7. This is a perfectly good method, though sometimes we do end up with, I'm going to call them unusual values or values that are harder to graph, like -1/10. That's kind of a harder value to graph, especially if we're using a homework system or any kind of digital system. Another is to create a table of values. So in this method, you literally just pick different values for x, plug them into the equation, see what the corresponding y value is. Again, that can take some extra steps because if you don't get a nice coordinate pair, it can be harder to graph. So a third option, and the option that I like best, especially for graphing linear functions, since we already talked about the idea that this is by default going to be in slope-intercept form, y equals mx plus b, is to just plot the intercept and then use the slope. So we'll say using the y-intercept and slope to graph the function. All three methods are valid. I just like this third one because I think it's the easiest. I can look at this function and know that 4 is my y-intercept, or more specifically the point 0, 4. If I don't catch on to that right away, I could plug in 0 for x and find that. But once we have that point, we can plot 0, 4, and then use our slope, which is rise over run, to move up 1, 2, 3 points, and then to the right 1, 2, 3, 4, 5, 6, 7 points. To get a second point for our line, which in this case is the point 7, 7. Again, the other two methods work, but when we have the slope and the y-intercept, assuming that our y-intercept is a nice whole number or something that's easy to plot, we can use the slope as rise over run to move up or down and to the right to get to that next point.